How's it going, everybody? Welcome back to another .NET video. I want to cover RabbitMQ, but I want to cover it from the context of RabbitMQ's native client. And the reason why I want to do this is mainly due to the fact that mass transit is going commercial. So I think there's a little bit more incentive to actually put a little bit of time into learning RabbitMQ's client. So I want to show you the general interface that we're going to be walking through, and that is going to be for publishing a message to an exchange that's going to be bound to a queue. It's going to get messages from a stream and also getting messages from a queue. I want to show you how to do this with endpoints, a background service, and also the proper configuration that you need to use RabbitMQ Client to connect to a stream. And there's a difference there because there is a RabbitMQ stream protocol library for .NET, but I'm going to be using the RabbitMQ client library. So what I mean by that is I'm going to be using this here, the RabbitMQ.client. There is another one that's called Stream Client, which is a different protocol than the AMQP protocol that you're going to be working with in the RabbitMQ client. So for this video, I'm specifically going to be using this NuGet package here, the official client from RabbitMQ. So let me actually scroll this down here so I can show you. So I want to talk about this because there's a lot of information about RabbitMQ online, but a lot of it is in the context of mass transit. And so this raises a couple questions, or at least it did for me, and generally in terms of how do I consume messages continuously from a queue? And also, how do I take advantage of replayability inside of a stream in RabbitMQ? Because replaying is advertised as a feature, but when you talk about it at its functional level, what does it actually mean to replay a message? I know you can plug into any time in your stream given a specific offset, but what does that actually functionally look like in the context of an application or system design? Because a lot of I would say a lot of the examples that I found online are always in the context of a console application, but a console app is very limited when we're thinking about system design in the context of APIs. So if you have an API, you may not want to introduce just a console app that uses a console.readline statement to wait for messages. So that's the problem I was having when I was looking up this documentation. So I want to walk through what this looks like in the context of a functional .NET API. And so this is my car data API. And I went ahead and made a service just called RabbitMQ service that this is going to house all the responsibility for connecting and receiving from RabbitMQ. I just defined some constants up here, so this is generally what we're going to be working with. Let me size this window here. So I have a couple queues and streams made. So this is my engine data queue, set to durable. It's just a classic queue, and I'm not trying to think if there's anything other I did here. Okay. So I want to show you, I just want to send a message through here and then show you my consumer consuming this. And then I'll break it down. So let me go to my background service and let me make sure that a breakpoint is set there. Okay. And the nice thing about the management UI in RabbitMQ is that you can just send messages right from here. So I'm going to go ahead and publish that message. You can see that it immediately gets picked up. We're going to step over that and we're going to look at what the message is. So that looks correct. You can see it logs to my console, and then I'm going to continue. I'm going to publish another one. You can see that gets picked up, and we'll do one more, and you can see it gets picked up there, and I can continue. So this is my background service, and that's what we're going to get to in the video, but I'm going to start first at my service for just retrieving messages based off of an endpoint. So I'm going to go and actually comment out my hosted service so I don't consume messages from that queue on my hosted service. I'm going to restart my application, and I'm going to show you the endpoint that I'm going to hit. So I'm going to go to my controller, and the endpoint responsible for connecting to the queue is going to be get car messages here. So what I'm going to do is actually fire off a few messages to the queue. So I published a few messages there. Go back to my application, and let's go ahead and look at this code here. So this is the code that's going to be called, and I'm going to I should hit this endpoint or this breakpoint there. So let's go to my Swagger UI. Going to go ahead and go to get car messages and execute that, and you can see that I received 1, 2. I don't know how many messages sent. I might have sent like 3 or 4. I think I might. Is that 4? Works. I don't know how many messages. Let's see. I have a lot of console logs from other things in here. Well, there's somewhere in there. But you can see how that works. And if I hit this endpoint again, it's not going to get anything because I've already gotten all the messages off of this queue. But if I were to go to publish a couple messages here, you'll see this number rise. The publish rate spikes up to, what is it, .40 a second. And then you can see I have ready 2. And if I go ahead and execute that again, step through that or continue twice because there's 2 messages, you'll see that this will go back down to 0. So let's break this code down because that's obviously very different than having a background service running. So the first, when you look up RabbitMQ documentation, you're going to be presented with a few core ideas and things that you have to do regardless of the specific language or framework that you're using. So I did my best to comment on top of all the core things happening. The first thing you're going to want to do is define your connection through this connection factory. And for me, all I did was just pull down the latest Docker RabbitMQ image, but I left my credentials alone. So this is just running on localhost for the host, and guest is my user and password. So that's the connection factory that you have to make. The next thing that I did was define my cancellation token source, which I have a video going in depth of cancellation tokens in .NET. Cancellation tokens are literally just flags that the .NET framework has decided it's going to use to handle stopping code. So a lot of methods that you work with in .NET have an optional parameter to pass in a token from a cancellation token source. So I went ahead and did that. And you can see that the next thing I have to do is actually build my connections. So to do this, you're going to want to use that factory that we just defined here, and then you call create connection async. And then optionally, you can pass in your cancellation token. You're going to want to make sure you have this wrapped in a using statement because this needs to be disposed. And so using statements in .NET are basically just fancy syntax to call the dispose method when this goes out of scope, right? If you don't have to use the using if you don't want to. If you don't want to do that, you could do something like a try catch, and then you could add a finally block at the end, and then you could say like, connection dot dispose. You could do something like that. So that's an option too. It really actually depends on how you want to structure your code because sometimes using statements don't actually make the most sense. Sometimes you may want to leverage a try catch finally block depending on your specific scenario. But I would probably, especially upon initial implementation of this, I would probably go ahead and use the using statement just to handle your scope. So you're going to want to do that for the connection, and you're also going to want to do it for a channel. So let me explain what a channel is. So a channel is RabbitMQ's basically virtual TCP connection to your client. So when you have a RabbitMQ server, when you connect to it, you're connecting via a channel. So if we go back here, you have to open up a channel, which is your connection to communicate with RabbitMQ. So once we have that channel created, again, I'm passing in my cancellation token. We can then use the channel to now communicate with RabbitMQ. And one of the first things that we're going to want to do is define the exchange. So you can call this code here to declare your exchange. Now, this is optional actually. So if I were to go into RabbitMQ and look at my exchanges, you can see that I have a list of many exchanges because I use this for all my stuff. But if I go to exchanges and I go to my car exchange, this is the exchange that I'm declaring to make. But the reason I say it's optional is because if you don't make an exchange, everything automatically by default will get routed through this top fan out or this top direct exchange that does not really have a name in all intents purposes, but it has, anytime you publish a message, it has to go through an exchange through RabbitMQ. An exchange is the router mechanism for your messaging. So you're probably going to want to go ahead and declare an exchange and then give it an exchange type. So in my case, I gave it a type of fan out. You have other options like direct, topic, or headers, different things like that. So I'm not going to go into the detail of all those right now, but we can after this. So once you have your exchange declared, you're going to want to declare your queue. And so the queue is what the message is going to get routed to. So you have to declare your queue and then give it a respective queue name. In this case, I'm giving it a queue name of engine data. And then you pass in the necessary parameters. And the parameters for declaring the exchange are going to be, you're going to want to set it to durable, because if your server goes down, you don't want your exchange to be deleted upon your server being, coming back. You're going to want to have auto delete probably set to false. And then again, optional, you can pass in your cancellation token. A queue is going to have a similar set of parameters. So you have your durability setting. You have your exclusive, and we go over that. Exclusive is basically just, I believe exclusive, if you mark it as true, it'll make it tied exclusively to one consumer. I think, I could be wrong about that. There's a lot of parameters and configuration to this. Again, auto delete is set to false. I don't have any arguments here, but I'll get into arguments when I talk about streams, and I pass in my cancellation token. So once I have those two things created, now I can do code to basically bind my queue to my exchange. And what that means is when I go to my queue and I go to my, engine data? Yeah. If I go down to bindings, you can see that I have a binding to my car exchange. So if I actually go to my exchange here and I go to my car exchange, I go to bindings, you can see that this exchange is bound to my engine data queue. And that was done through this code here. So it's pretty straightforward, the syntax for this. You give it your queue, you give it your exchange you want to bind it to. You can specify a routing key, and again, you can specify specific arguments. Routing keys don't apply to fan out exchanges, but if you're using, let's say, a topic exchange or a direct exchange, you can set something like an X, filter value to, or sorry, not a filter value. You can set like a header property to route on. You can set a routing key. So like something on like a topic exchange, everything is done through dots. So you could do like, log.error is one, would be one route. Another route would be like, log.info, whatever. So again, that parameter here depends on what type of exchange you're working with. Again, I have no arguments, but again, I'm going to get to those in a little bit. So once I've defined this, I've created my exchange, I've created my queue, I've bound the two together. Now I have to get let's see. Now I actually have in order to publish to my exchange, I have to set the encoding for my message. And you can just take the message here, which is a string, and just encode it to UTF-8. So now I have a body of bytes, a byte array, and that's how you're going to want to encode your message prior to sending it to RabbitMQ. So if I go ahead and actually, let's go ahead and actually run this here. I want to show you a publish message, and I'm going to say hello, and I'm going to execute that. Now I'm going to go back to my queue and go to my engine data. You can see that my publish rate spiked, and you can see that I have one message there, and that's the message I just published. So that code that I just fired off in my publish endpoint is running through all this. And the next thing you'll want to do is, very importantly, you want to set the persistence flag on your message. So it's not enough to have your queue and your exchange marked as durable. You also probably want the message itself to be marked as durable or persistent. So if you hover over persistent, it specifically says that it sets delivery mode to either persistent or non-persistent. And that's important because if you set your message to not persistent, if it's not persistent and the server goes down, despite the fact that your queue may be set to durable, if your data is not set to be persistent, the data will be lost. So depending on the data or the type of data that you're working with, you're probably going to want to make sure that this is set to true. So that's a very important bit of information to make sure you capture. And so you will set properties, or you'll pass these properties of type basic properties. I actually don't know what other properties. Let's see, it gives you persistence, app ID. Oh, okay, here's where you can set correlation ID and expiration. You can see I can set headers, the message ID. You can set a lot of things on your properties, which is very handy. So if you want to actually write some custom code to interact with, different headers or whatever, you can basically tack these on to your message properties, which is nice. So it's nice to have this manual control over it, especially if you're coming from somewhere like a library that wraps around RabbitMQ. You don't get this tight control over some of these manual options. The next thing you're going to want to do is your actual publishing of the message. So once you have done all this, basically making sure that everything is set up correctly in your RabbitMQ infrastructure, now you can publish your message. So let's go ahead and set a breakpoint there, and I'm going to run my publish car message, and you can see that I hit this breakpoint here, and I want to show you all the data that's tied to this. So I have my exchange name of car. I don't have a routing key because I'm using a fan-out exchange. If you don't have a routing key, I would probably assign it to string.empty as opposed to like an open string or anything. So mandatory, I think you can probably leave for false for right now. You probably want to read up on what the implications of mandatory means for your system. Basic properties is where we pass that object in. But you can see everything that you can potentially assign to the property of that message. So you get a lot. And we're not going to go into this. We don't have nearly enough time to go into all this on this video. I will make a follow-up probably set of videos covering these properties, but there is a ton of information here that is really, really powerful and important as it relates to your system and how you structure your system design. The one thing I will call out, though, is the timestamp. The timestamp is very important because the timestamp we're going to use as it relates to streams, but I just want to show you that if you want to mark your message with a timestamp, AMQP has a AMQP timestamp class that you can pass in a Unix epoch of time, and that can basically allow you to filter by time, which is very, very powerful. And again, so there's just a ton of stuff you can do. Correlation IDs are obviously very important if you want to add tracing into your system. Uh, Expiration, I think, which is the time to live value. So if you want it to expire in 5 seconds, you can set that. I don't know the syntax. I think the syntax in RabbitMQ is like if you want to set it to like 1 second, I think you actually do like 1S. Because I know days, because I work with days more, it'd be like 30D. So you just have to read up on the syntax. But again, you're not going to probably remember all the minute details of all this stuff. But you can see the body is my array of bytes and my cancellation token. So I'm going to step over. Well, actually, I'm just going to continue that, and it's going to publish to my. It's going to publish to my queue. I'll publish to the exchange that gets routed to the queue. And then once we do all of that, now we can come back in here and we can close the channel and close the connection. So close and dispose. That's what you got to do at the very end. However you do that is really up to you and how your system is structured. Again, if you want to use a try catch finally, if you want to use using statements like I did, but regardless of what you do, make sure that at the end of your code execution, you have disposed of the resources and you've closed the channel and the connection. This is important because you need to. It's opening a channel is a rather expensive operation, and I don't know how much memory it actually leaves on what the memory footprint is, but make sure that whenever you're done executing this, you close and you dispose of your resources that you're using. So when you look at this, it is a lot of code to just publish a message to RabbitMQ, which is why libraries have come along and made this a lot easier to do. There's a lot of excellent libraries out there like Mass Transit that make this so much easier and basically remove all of this knowledge of like things you have to do and just allows you to think about more of like how you're using RabbitMQ rather than like the configuration just to use RabbitMQ, if that makes sense. So that is an example of an endpoint calling a publish message to a RabbitMQ service that I made. But now I want to show you what the code looks like to get the messages from RabbitMQ. And I showed you that endpoint being called, but I'll show it to you again. So I have a get car messages endpoint. I'll execute that, and you can see that I immediately jump down into my event that I have that you can see that this is receive. It's a receive sync event that we added this event handler to, and that is going to process my code. And you can see that I get my array of bytes, and let me step through, or let me just continue that. And I don't know how many messages are in there. All right. Let me give myself my debug tools here. All right, so jumping up to this code here for the actual getting messages off of a queue, it's actually very similar to publishing in the sense that you have to make the connection. You don't have to, you can optionally make the cancellation tokens, you build the connections, but then you have to redeclare your infrastructure, your exchanges, your queues, and you bind them. That's just standard code that you do that makes sure that is basically just making sure that the things that you're using in RabbitMQ are there. So whatever documentation you come across in RabbitMQ, this is always the approach that they tell us to do. So that is basically any language that you decide to do this in, you're probably going to have to do some version of this. So once you do that, the difference with this is, as opposed to our basic publish async method, now we have this consumer, which we define as an async eventing basic consumer. And it says a constructor which sets the channel property to the given value, And then once you have this consumer, now you have this, which is your async event handler. And then you can add an event to that. So it's event fired when a delivery arrives for the consumer. And then so its handlers must copy or fully use delivery body before returning. Accessing a body at a later point is unsafe as its memory can already be released. So now what we've done, we're adding an event handler to this. We're adding an event to this receive async event handler, which basically just allows us to get the message, encode it to UTF-8, get the string, and then we're going to write to console. And then I'm just going to return a completed task. This, again, depends on how you have this structured in your code, but this is just one way to do that. So the syntax is a little odd. And I want to call out a couple things because after you create your consumer, you have to then call this basic consume async and then pass in that consumer as a property. So you can see that I have to pass in my iAsync basic consumer into this basic consumer method. And that's just what you have to do. And I want to go through the parameters of this because I think it's going to be important. So you can see this is an extension method on iChannel, which is our channel. So you have to pass in the queue. You have to pass in the acknowledgement setting. So if I were to, right now I have my acknowledgement setting set to true, but if you want to set that to false, that means that if you were to process this, but you don't acknowledge it, RabbitMQ is going to actually send that back to the queue to process later. And I'll show you that, and I'll show you actually setting it to false because I think it illustrates a good point for this code. And this is probably going to be a long video because there's so much detail about connection to RabbitMQ to make sure that you understand the nuances of not only the protocol, but the settings to get this right. So I want to publish a couple messages to that queue just so we have some data. So let me just publish a couple messages. Again, having an endpoint just makes it easy to interact with. So you can see that I have some messages here. Let's go ahead and refresh that. I think it should be about 3. All right, so I want to go back to my get messages endpoint. I'm going to set a breakpoint right here. So let's go ahead and get my messages. Let's fire that off. And, oh, what happened? Hold on a second. Get messages. Let me go back. I need to set my breakpoint in a different spot here. Hold on. There it is. Okay. That was actually a good illustration. All right. Okay. You can see that the functionality has already changed significantly. Okay, now I was like, wait, why didn't I get into that body? Okay. So you can see that my message is hello, doing everything. But now the big thing is I'm not acknowledging I'm not sending an ACK back to RabbitMQ saying that we received the message successfully, which is important because RabbitMQ, so you can see that I jump down to here, close my resources, and you would think I'm done. So you would expect if I go in RabbitMQ that my queue would be 0, but it's not. You can see that see this crazy graph. You can see that at this point here, I can't get to stop, but it goes down to 0, but then it goes back to 3 because those were unacknowledged messages. And let me see if I can get that to show because I think that will help. Let me set a breakpoint there and let's see if I can do that again. Okay. Basic consume. I'm trying to get it to show my unact set to 3. I might have to step past that. And okay, perfect. You see how that went from ready to 3 to now unact is set to 3? That's very important because that illustrates how what's happening behind the scenes. When we create our connection when we create our channel to communicate to RabbitMQ, we're operating a TCP protocol. So when we receive a message, we have to send an acknowledgement back to the server, an ACK, right? If RabbitMQ doesn't receive an ACK, then it's going to re-queue that message on the queue with the default settings. Now you can get around this. You don't have to send acknowledgements back, but you have to specify that. In the default setting, you have to send an acknowledgement back. Otherwise, if you don't, whenever your code finishes, those messages are going to get queued back up on the queue. So they're going to move back from unact back to ready because RabbitMQ says, hey, wait a second, these were never act, so let's put them back on the queue. So if you don't acknowledge your messages correctly, you could run into a scenario where you're reprocessing the same messages thinking that you're acknowledging them. So you got a couple options here. You can either set the auto ACK to set to true, which is by far the easiest way to do it, and it removes any kind of complexity in terms of acknowledging. Or what you can do is on the channel itself, you have a basic ACK async, and there's a couple things that you have to define. So when you have a delivery tag, which is going to be unique to your specific message. I do need to make this async, thereby removing the task completed. And it does tell me that I have cancellation support. So let me go into the parameters here. So basic ACK async is asynchronously acknowledges one or more messages. In this case, we're going to acknowledge one at a time, so multiple can be false. But the important thing is that you pass the delivery tag of the message back up to the ACK so that it knows, okay, this is what it's acknowledging. You may think you're done, but I want to show you something because this is, and if you have acknowledgement, you probably want to set this to false. If you're manually acknowledging, you probably don't want to acknowledge twice. So you may add this code and you might think you're done, but I want to show you a huge gotcha that I think can trip you up. So I'm going to restart this and I'm going to go, okay, let's restart this. Now we have a manual acknowledgement. Oh, and by the way, this squiggly here is just saying that this channel is disposed outside of the scope of this in case it, for some reason gets disposed before you act on it. So that's all. It's just warning us. So now I want to go back to here. So I want to, I have a breakpoint set on that same spot. So I'm going to go ahead and fire off that get car messages. It's going to go here. Okay, looking good. We're acknowledging messages. Perfect. But I want to show you something. I want to go to RabbitMQ and look what happened. My ready is 0, but my unacknowledged is still 3, which is interesting because you're like, wait a second now. We should have acknowledged each of those messages. And you would think, based on how you're reading the code, I thought that as well. When you're looking at the code logically, it looks like, okay, well, at the end of, I'm getting the message, I'm writing it, and then I'm going to, do an acknowledgement back of that message. And you can see that, well, let me actually stop here. Let me do this again because I had a breakpoint set and that breaks the example. Let me go back to and publish a couple messages. I think you know where I'm probably going with this, but let me put a couple messages up there. And all right, we got the messages back. Now I want to run this again. And I'm going to get the stream messages. I don't have any, whoops. Oh, I don't have any breakpoints set. And well, hopefully I don't have any breakpoints set. Let me go to get car messages. That's my endpoint I want to be hitting. And you can see that, okay, I should see those messages got processed. They got, outputted to the console. But if I go back to my queue, it still shows 4. And you're like, wait a second, I thought we acknowledged it. You can see clearly that, let me do it again, because you're like, okay, maybe it just was like kind of like a fluke in RabbitMQ. It's not. And you can see that I am getting my messages, but they're still getting back to ready, meaning that they have never been acknowledged. And reading this, you're like, wait a second, it seems that I'm acknowledging it. But the problem is that depending on how your event handler is set up, you see that on this channel, the basic ACK is an asynchronous method. And so what is happening is basically that essentially what is happening is that this channel is effectively being closed before our acknowledgement has time to complete, which is why when I set a breakpoint, effectively, pausing that task here, the acknowledgement was able to get back to RabbitMQ. And so that is a big gotcha, because if you write code like this, if you write your asynchronous event handler, and then you go, okay, well, I'm going to have an async, basic ACK async, and it should all be good. You might run into a task completing before your acknowledgement gets sent through. So that's one gotcha that I found with some of this code. And some suggestions that I found online always revolved around this, having to have manual intervention in order to delay the execution of your disposal so that your acknowledgement can complete. Now, you don't have to do that. You don't have to truly make this asynchronous. You don't have to maybe await. But since it's an asynchronous task, you don't want to call .result on there, because you don't want to potentially do a deadlock. You don't want to spin this into another thread with task.run, because if this still closes, you may run into the same problem. So what do you do in order to avoid manual intervention? And one way is basically just doing what we did, via breakpoint. So I'm not saying that this is the 100% best way to do this, but I want to show you something. So I just gave it a nominal amount of time, and you'll probably have to figure out the time yourself depending on how you have this set up and structured. But I want to show you what basically what the implication of this is. So again, you can see that I back up to 4. I'm going to go ahead and call that car message endpoint, and let's see what happens to my ready count. You can see that it spikes back down to 0. So again, this gets into threading. It gets into tasks completing prior to another task, finishing. Obviously, you have options here, right? You have options. If you don't want to do a task.delay here, you could do something like a task.continue with. It's an interesting problem. So this gets into how you want to structure your file. Obviously, you just need basically a callback, essentially, upon which this dispose is called after the fact of this basic acknowledgement running. So you need some basically version of continue with on the task. But the problem with that is that this is contained in that event handler, so you're gonna have to structure this somehow. So that's just one interesting thing that I've come across that I haven't seen a whole lot of documentation on. outside of the context of that console read line, which again is good for console apps, but we're thinking in terms of a API. So again, there's different strategies here. You probably might not want to use the task.delay approach, but I'm just showing you like what has to be done in order for a manual acknowledgement to be sent. If you don't care about manual acknowledgements, you don't have to worry about it. You can just set auto act to true and be done with it and call it a day. You don't have to worry about it, which is by far the easiest thing to do. Why you might want to do manual acknowledgements is if you have any sort of custom logic here that you want to have acknowledged, depending on, let's say, you're making an API call with the message from RabbitMQ, you're inserting into a database, you're acting on the message somehow that, depending on a result of something else in your code, you either want to acknowledge the message successfully or you want to not act it and then have it get requeued to RabbitMQ. So this gets into retry policies, because retry policies around RabbitMQ really revolve around acknowledgements, right? Because if you don't acknowledge it, it gets requeued, which essentially is a retry. And so this depending on how you implement basic or manual acknowledgements, is basically going to dictate how you want to implement your retry policy. But again, it gets complicated quick, and it really depends on how everything is structured. So obviously, no way we're going to be able to get to in this video, but I want to show you one gotcha around manual acknowledgements and how you have to accommodate for the fact that you have to get that task to complete before you close all your stuff. Now, because these are asynchronous methods, you can chain the methods together with continue with. You could take more of a functional programming approach and bind the methods together, which is probably what you may want to consider doing. But I don't have time to do that code right now. But hopefully this gets the point across. So that is a lot of how you consume from a message. Now I want to get into streams. And streams on the RabbitMQ client library are not only very limited in terms of documentation, but I just don't know if I've seen a lot of documentation, if any, on using streams in the context of .NET with the RabbitMQ client library. Yeah, and you can do it, and it's pretty similar to how you would set it up for a queue. You go through all your declares, you make your exchange, but the first thing you're going to immediately notice as being a difference is this queue arguments. So queue arguments is just a dictionary of string object. The first one is this XQ type, and headers or arguments in RabbitMQ are usually prepended with this X dash, whatever it is. So if we go back into RabbitMQ, I want to show you my stream here. I think it's engine data stream. What is it? I think it's engine data stream. If I go here, you can see that I want to get to the features and the arguments. You can see that these match what I specified here. So your queue type needs to be a stream, but then your max age value should also be set, because RabbitMQ operates on it uses amnesia as its table, and it uses segments to house the data, and you'll have multiple segments depending on your segment size and basically how much data you're pushing through RabbitMQ. So your stream, you don't have a typical time to live as you would a queue. You can't set that. On a stream, you have a max age of the data on the segment. But the thing is, there has to be one segment present, and there always will be if one data is there. So even if you have a max age set and you have data in one segment, that data might still be there because you always need one segment. But if you have two, the second one might get dropped. But it's very confusing. Basically, it's not like time to live. It's not the same way of thinking about it, but you need this value set because you don't want to always, hang on to all your data, right? It would probably, grow out of the size of your disk. The next thing that you need to set, and it's required, is your QoS setting, which is your prefetch setting. So RabbitMQ, the protocol, you can think about this as like your buffer, right? So if you ever worked with like Mac on Unix, you have your buffer. Uh, I'm trying to think of how to talk about this. It's your buffer setting. So when you go and you make that connection via the channel, your prefetch count is going to basically fetch those up to the prefetch count size that you specify. And so once we establish our channel connection and our code is running to receive, we're going to retrieve this number of messages through the buffer every time that we consume from that stream. It's again, this kind of like hurts my brain thinking about this, because it's just so much more information that you have to know that you wouldn't have to know if you just use like a library. And so again, there's a lot more setup, but this has to be set. So otherwise you'll just get an error from RabbitMQ telling you that this isn't set. So you set that on your channel. So once you get that set, then you can declare your queue. You're going to pass in your queue arguments. You have a lot of arguments that you can potentially set on the queue. So this is not what it's limited to, but these are the ones that you'll need to specify. So once you have those set up, you'll want to also make sure that your durability is set to true. Your auto delete is also probably set to false. And durability for streams can't be false, I believe. And then once you bind your stream to your exchange, again, it's not going to have a routing key. I don't have any arguments. And then everything else is rather the same. In this example, I am actually going to use just a console read line because I want to show you basically when I publish to my stream that I'm just going to consume it here. I want to show you actually, before I get into the next bit of code, I want to show you this running. So I think I have a breakpoint set. Let's see if I can get lucky and publish to the stream and have it work. All right, test and test. Let's publish that, see what happens. Did I get it? I might not have. Oh, because I never called the code. Hold on. There it is. It should be that test value. Test and test. There we go. And then obviously I have my console read line statement running, so I'm just going to publish another message and you'll see it. There it is. So the console read line, that's always the code that I see in the example. So, but again, I just don't see much in the context of an API. So I'm trying to fill that gap. But I want to get into this because you'll be like thinking, okay, well, in my RabbitMQ stream, you can see that I have 22 messages. Why did I not get 22 messages here upon execution of that code? And the reason for that comes down to my consumer arguments and offsets. So the way streams work in RabbitMQ is that it works with an offset table. So your consumer, when it connects to RabbitMQ, the stream, it's going to then have a log in an offset table that's going to be tied to where it left off in consuming messages. So if you were to consume 3 messages and then quit your consumption, dispose your connection, that 3 would be logged in the offset table. So next time you connect, it would say, okay, let's go look at let's look up first what the offset is and resume from there. By default, if you don't specify an offset, it's always just going to use where you left off, which is probably what you're looking for out of the box. But where the real power of streams comes in is your ability to go in reverse, or to time travel backwards, or to pick a specific offset number, or maybe just all the way at the beginning of the stream. And you can do that here by specifying consumer arguments, which again is just the same thing as your parameter was, a dictionary of string and object. And then you get this fancy argument that you can set. It's called extreme offset. And the options you get are last, next, first, which is basically it always starts at the beginning of the stream. It's only going to get any messages after the point of connection. Next, which is just, I believe, next is wherever it left off in the offset. Last is, is last? I think last is the beginning. I think I could be wrong. Timestamp, which if you remember back earlier in the video when I showed you that Unix epoch timestamp that AMQP has that fancy class for, that's where this is going to come into play. And also you can specify a specific offset number, but how would you know that number, right? That's kind of where I'm like, how would you know that? If you want to go, meaning offset number is like, I shouldn't say how would you know that. I should say offset number is used. I shouldn't have said how would you know that. Offset number is used like, okay, I want to start always five messages back, right? If I specify 5, it's going to start, hey, whatever the first is, go back 5, and then just start from there. So that's how that's used. But I want to show you how timestamp is used. So you can see that I'm not actually using the consumer args here. I'm using them down here because I'm actually using a timestamp offset. And this took me so long to figure out because there's just no examples of this header that I could find in .NET. So here it is. This is what I found to be true. So many threads, many forms, many prompts, trial and error, until I figured out that based on a little bit of wording in the documentation, RabbitMQ in streams uses a timestamp in seconds in Unix time. But in order to do that, in order to leverage that timestamp that gets tagged on your message that's in your stream, you can't just use the Unix timestamp. You have to wrap it in this AMQP timestamp class. And you have to pass in your Unix time, which is just wild. You can see all the different crazy stuff that I tried. I tried doing date time offsets. I tried doing math. I tried to get in I tried a bunch of stuff, but this has been by far, well, this is what's worked. And this is, I think, way more straightforward. So for me, because I'm specifying to go only back 10 minutes, that's why you didn't see me get the messages in the beginning of the stream. But if I were to say go back, add days and go back 10 days, now let's rerun it. And I want to show you what happens as soon as I call this code. It's going to get everything from the stream. This took me so long to figure out. Because of the syntax, it's just nowhere to be found. So if I were to go here, it's going to get a ton of messages. It's going to get everything from the stream. So I don't want to step through, but I think you kind of get the point. So I'm just going to finish that. And I think you can see that it gets all my messages from the stream because I went back 10 days. So I'm actually going to, I guess, leave that. So the code to do this is right here. So give this a shot. And this presents the unique possibility of using replayability. And now this finally gets into, it took us an hour, but we're finally at how in the world are you using replay in an actual legitimate setting in .NET and system design. This is one way to do it. So if you have an endpoint set up like I do here, like get stream messages, you could pass in a, let's say I have like a day parameter, right? Like I have a int days make sure you tag it from. I'm a big fan of from query as opposed to from route for reasons, but I'm not going to get into that. And I could pass in days, and now I have to copy that into my interface. Let's go up here and get stream messages. I'm going to add that there. Now finally, I'm going to add that to my implementation of there. Now I have a days here. And then I could pass in days to here. I still want to make an... Well, I'm not going to make a... I'm just going to pass in days. Yeah, I'll just remember to do that and make it a negative number there. Don't make it an unsigned integer. Otherwise, you might be, you might run into trouble. Okay, so I'm not going to run this because it's going to be the exact same. Well, I guess I can. Hold on, let's just see if I broke it or not. Just coding on the fly. We'll see if see what happens. Let's go back. I got to refresh this guy. Get stream messages. Now I have a days parameter. Let's -1. I don't know. I don't remember when I don't know how many messages that's going to get. I don't know how many messages were in the queue. It's probably going to be all of them because I just made this like yesterday. Yeah, it's going to be all of them. So, but if I do... Oh, I put the console. That's thrown me off so much, like having to hit that. I always forget. I'm like, why is this hanging? And you saw in the video that happened. But let's do 0. I don't think I'll get anything. Yeah, because it's not going to get... So, rough example, it works, but let's just go back to the code now because this timestamp stuff is just mind-boggling. How I'm telling you, it's one small thing in documentation, like half a sentence, telling you that it uses the Unix timestamp in seconds. Every prompt I gave it, always, and everything else always gave it to me in telling me to use milliseconds. That's just it wasn't correct. Like everything, make sure you're using seconds. It's not at the milliseconds. It's not at the milliseconds level of detail. It uses seconds. So what I did is just show you how you can basically implement replayability with the stream by using a timestamp offset with a parameter that you pass in. So when you talk about message replayability, it sounds a lot more fancy than what it is, to be honest, because when it's marketed as a feature, you have to understand how it would fit into an API and a system, because you can't just go and arbitrarily say, replay everything and call it a day. You got to be smart about it, right? So in an API like here, you have the option with streams to specify a custom offset, whether it's passed in through a parameter in your controller or, whatever it is. You have that ability. So I showed you how you can do it with days with a custom date time offset. Again, just one example of how you can do this. There is other options that are very unique, and I just don't have time to get into it in this video. But you can specify, and we'll probably do it in a later video, you can specify filter values. So I think it's like x.filter.value. Honestly, it might be the header, I think. You can specify custom filters to run on, I want to say headers. I forget where I might have the code somewhere. Maybe. I remember I made it one time. I can't remember if it was here or not. Yeah, it might not be in this project, so I'll have to find it. But I'll make another video in the future telling you how to use filters and how those can be used in streams. Very, very powerful. It's honestly pretty crazy. So if you combine filtering with custom timestamps, then you actually will have something going for replayability. And you tie that back to an endpoint that you can controllably call, then you can really make something very, very powerful. And that's where the power of streams really comes into play, because streams, if you leave the offset alone, it's basically going to functionally operate like how you would expect a queue would operate if you connect to it. So if you have a consumer off of a stream and you don't mess with the offset, but then you need some other tool that you can go back and get data every week or whatever, you can just add another consumer to that, or you can add a method, you can add something to connect to that with custom code like an offset or whatever to go back and get that data. So on the same stream, it's very, very powerful, but it's just getting here is painful. But here it is. Here's the code. So this is .NET. It's an API. It runs. But obviously the big thing is, okay, well, that's great, but what do we do about this? What do we do about this console read line? Because we don't want to just, always consume once from a queue or a stream or whatever. So what do we do about that? How do we continually consume from these things? And I want that in here because I'm testing with it, but let me show you one implementation, because, this is just a service, right? This is a scoped service that is going to be built, run, and, disposed of once on a request response lifecycle. But .NET has what's called background services. And background service is just basically an abstraction away from a hosted service that makes it easy to write code that will continually execute in the background. So if we go into our middleware, you can register these as a hosted service, and then you just pass in the type of your class, your object. So, but again, if you can imagine how painful it was to connect to RabbitMQ, you can imagine how painful it's going to be to write a background service to continually consume from that. I want to show you how to do it. So I'm going to show you. It's not straight. Let me tell you this. It's not nice. It's a lot of code, but it works. But I want to show you some nuances, and basically this whole video is pretty much just like why you should use a library, but a certain library, Mass Transit. You can't beat Mass Transit is just a phenomenal library, but it is going commercial, so you might have more incentive to maybe write some of these things yourself. So again, let me show you some possibilities that you can explore with .NET, because right out of the gate you do have background services. So that's where your mind should go whenever you think of a continuous consumer off of a queue is, okay, how do we use background services for that, right? Because that's something that is managed by the .NET framework, and you can use singleton class, services. If you have them, you can use whatever. But I want to show you one approach that will work. So again, all the same code that I had, it's all going to be the same. This I think is connected to my queue, not my stream, but it's going to be the same for a stream. So yeah. So again, we have identical code. I copied and pasted it from my RabbitMQ service. It's going to be making the factory, the connections, everything is the same. But what you'll immediately will notice is that I'm not using statements. You're like, hold on a second now, how does it ever get disposed? Because I have these defined at the class level here as properties. So I have a connection, and I have a channel, and then I have just my strings for the data. But you're like, okay, well, when does it ever get disposed? And so this is where the difference of thought comes in, is that, okay, this is a running background service that's going to run for the life of the our API. As long as the API is running, this is running. So it's never going to get disposed in the traditional sense like a transient service would, or or a scope service would. So these things have to be defined at the class level. You don't want these things defined here, because that's just going to basically make this loop. So you want these things outside of the scope of that, because you want our construction of these to be called once. once upon actual creation of our hosted service. So this is where the interesting bit of code comes into play. So I made just this build RabbitMQ connection method that basically builds up all our connections, assigns the properties to those things, acts on that. So now we have our channel available to us outside of the scope of just this build RabbitMQ method, because it's declared as a property on the class level. So, but the hard part about it is it's an asynchronous method, and I want to call this in the constructor, and the constructor itself, can't be, I can't make it return a task because it's a constructor. So one approach that you can do, again, you got options here, but is just spin up a new thread and run it on a thread as a asynchronous task. And that's what task.run does for us. It's going to basically run our RabbitMQ connection in the background on a new thread. So that'll work for us because that allows us to make it asynchronous and it does what it needs to do. And let me go into the execute async. So this is the actual required method that you have to implement when you inherit from background service. It's just going to go ahead and throw this in there for you to do. So protected override, execute async. So this is what's going to be called. So let's read this here. So the method is called when the hosted service starts. This implementation should return a task that represents the lifetime of the long-running operation being performed. So when you read that, two things stand out to us. This method is called when iHosted service starts. That starts when our application starts. So this implementation should return a task that represents the lifetime of the long-running operation. So now we have the challenge of, okay, well, what task do we return? Because we can't return a task from the event. Like we can't return, like here, we can't return the task here because that's going to mark it as complete. When it receives everything it needs to receive from the queue at the given time, if we have this return the task, then it's going to mark complete and then stop the execution. So what we can do is we can actually leverage our cancellation tokens. And if you watched in my previous video talking about cancellation tokens, you can register a callback to trigger upon cancellation token stopping. And so what I can do is that if our cancellation token stops, we can register a callback. So register a delegate is a method signature in .NET, but a delegate that will be called when this cancellation token is canceled. So I showed you this in my cancellation token video, but this basically is going to be executed when our cancellation token stops. And the only way our cancellation token is going to be flagged to stop is when our API gets torn down. So I made this task completion source, and a task completion source is the producer side of a task unbound to a delegate. And so a task completion source is basically the thing that basically builds the task, where the task comes from. So what I can do is I can call on there try set result, and it says attempts to transition the underlying task into a complete state, right? So that's when, okay, we're going to say, okay, now we have this task that was not ran to completion. Now, once our cancellation token stops, now it's going to run to completion, and now we can return that task. So because now we're going to be returning the task anyway. Like when all this runs, when we consume messages that are currently in our queue, this is going to return the task. But if it's not completed, then we're going to go back to the top and say, okay, keep going. But if this cancellation token gets flagged to stop, we're going to then say, okay, this task is completed. When it returns it from there, now it's going to return a completed task. And if it does return a completed task, it's going to stop execution, and our dispose is then going to run. So next thing, after we set up all that, is the dispose. You have access to to override the dispose method. Just go ahead and close your channels and dispose them. And I just went the extra step and I just set my strings to null because I had those specifically defined. But the thing about this is, like, this dispose here Uh, we're not expecting the hosted service to dispose basically until our .NET app goes down, right? So, but all that to say is it's not. I wish it was like. I wish it wasn't like this, but this is the general code that you have to structure in order to create a listener to that queue. So I'm going to go ahead and go back to my middleware, and I'm going to uncomment that. So I have a listener to my queue, and I'm going to go ahead and start this. So now my hosted service is registered to start, and I don't know if my queue had anything in it. Probably not. Let's go ahead and go to my queue. Is it engine data? I think. What's the queue? I always forget what that queue name is. Yeah, engine data. And I got these endpoints that I can just publish some messages to. I'll just publish hello. That's going to send it to my queue, and you can see that it gets picked up by my background service. So pretty handy. I am going to then continue that, and let's go ahead and send another one. And then you can see it gets picked up there. And again, so this service is just running. So anything that gets sent to that queue is going to get picked up. So if I just spam it with messages, like if I just, test works, whatever you want to call it. If I just, if I just spam the queue with messages, you can see that it picks up everyone. So let me just have this running. So you could just have this running in the background. That background job is just going to process this and do what it needs to do. So you can see that, right? Console log, it does that. If I do another one, you'll see that it outputs to the console again. So this, we've just made a consumer off of our queue. You can do the same with streams. You can do the same with queues, whatever you want to do. But this is just one approach of how you can use background services to create a queue, a listener to a queue that will just run. And you might be thinking, or what should come to your mind is, okay, what's the memory footprint of having this channel open and continually processing messages? Well, we can test that. And the way we can test that is I have, you can do a couple things. I don't know what the, hold on. If we do .NET counters, or .NET, what is the command? .NET counters. I want to look at the list of processes. All right, so 84743, and then 84743. If you're curious about .NET's basically memory utility, I made a video about it showing how you can use this to identify memory leaks. But basically, you can install .NET counters globally, and then you can look at the running process of your application. Then you can run monitor and pass in that the process, and now you get a list of all your memory information. So you can see if I just I'm going to publish a bunch of messages to that background service, and then I'm just going to go through the endpoints too and do all that stuff. You can see that, okay, stuff is happening in my garbage collection as I'm doing that, but it's all getting disposed of properly, it would appear. There's not a lot of spikes happening. Memory looks good. So again, this is a very rudimentary approach, but if you really are concerned about memory footprint of your RabbitMQ consumer, this is one way to test that. So, and fairly easily, and it's built into .NET. You don't need any external tooling. But again, it looks pretty good. Obviously, this would need to be properly load tested. It would need to be running for a while to see if there's any, obvious memory leaks with our implementation. But obviously, we can come back and refine. We can come back and say, okay, what are things that we could do differently? But again, just thinking about it, this here this running service, we see how much more involved it is to do that manually as opposed to just using a service like mass transit where we can just say add consumer and that's it. But the one thing I will say that it is nice to have control over is the manual manipulation of the message itself. We don't have to know the type of the message from our queue, which is very, very nice because it can be more dynamic and we're not specifically tied to that type and certainly not tied to the namespace of the type, which some libraries mistakenly tightly bind you to the namespace, which is crazy. Mass transit doesn't do that. Mass transit you just basically have to just specify the JSON serializers and to do that. But if you have tight control over it manually like this, it's really easy to work with. But again, there's just a lot of overhead you have to do and a lot of stuff you have to set up. But so to wrap all this up, we made endpoints to interact with RabbitMQ. We made a service to interact with RabbitMQ. We made a background service to be a consumer off of our queue, and it can be a consumer on your stream, whatever you want it to be. And we went through some of the arguments that you can set on your queue, but there is a lot that you can do and a lot more. Like I didn't even get into the reply to, I didn't even get into proper error queue handling. I didn't get into any of that. That could be hours and hours more of content that, to be honest, I'm probably going to make in the near future on this channel. So thank you all for watching. This was a very long video. And yeah, I'll see you on the next one.